Hello dear student, welcome to the course titled Digital Communication. This is a chapter from your paper Advanced Electronics 1. This is a 16-hour portion and this will be taken online. The basic goal of this course is to provide you some understanding about the basic principle of digital communication, and also we study the techniques and the design and how to analyze digital communication systems. We say we live in a digital era. Digital communication play a vital role in today's electronic world. Digital communication is a physical transfer of data from one digital form, one point to another, and this transfer of data take place as a digital bit stream, as a digital signal, and this happens over a channel from one point to another or from point to a multi-point over a communication channel. And here the messages transferred are discrete messages. And everything we use today, such as emails, phone calls, video conferencing, instant messagings such as SMS or web chats, even the blogs, podcasts, the videos we watch, etc. come under digital communication. Let us look into analysis between the analog and digital communication. Hope you have already learned analog communication in your former chapters. So I will be just briefing through the differences between the analog and digital communication. The pioneer telephone network and the radio broadcast systems employed analog communication. The methods such as amplitude modulation, frequency modulation, you have already seen this. You know that the quality of the message such as speech or images that is received over analog communication completely depends upon how well or how successful are we in reproducing the baseband waveform which carries the message over a physical channel such as cables or twisted wires, etc. The channels here that the analog communication, the message signal requires to be of infinite set. And the challenge we face here is that we have an infinite set of possibilities of the waveforms because the analog signal itself is continuous and we have an infinite set of possibilities of the waveforms which we could use for transmission. The message itself, say audio or video, is continuous and therefore we need it to convert into a voltage baseband waveform. Hope you have already learned this, so I am not going into the details. We convert it into a voltage based baseband waveform, and this voltage baseband waveform is also continuous in range of amplitude, and this also have an infinite set of possibilities. And this baseband waveform, what will we do next? We just use an RF carrier. An RF carrier is modulated according to this message, and this RF carrier also is analog, and thus we have an infinite set of possibilities of choosing an RF carrier also. And this modulation can be AM or FM, and we have possibilities in choosing that over. And also it is being sent to a channel, and inside the channel also we encounter noises. We have crossovers from other communication channel, or maybe imperfections in the channel may add to the noise, which is also an analog signal, and we have infinite set of possibilities for that also. So in the receiver end, the main challenge is that we have to select, or this received signal have to be modeled through an infinite set of possible waveforms. and this actually reduces the fidelity of the received input over an analog communication channel. And the fidelity of the received message depends on the signal to noise ratio inside that we receive, and this fidelity is highly compromised in an analog communication channel. And to increase the fidelity, say increase the signal to noise ratio, we need to use high power transmitters, which we actually use in AM radio and in TV broadcasting. Also, we know that FM radios, we are familiar with FM radios. FM radios actually transmit in megahertz or kilohertz. So the radio broadcasting, we can see that the analog communication does not use either the power, because we need high power to increase the signal to noise ratio, nor it uses the bandwidth efficiently. Neither the power nor the bandwidth is used efficiently in analog communication. And also at the receiver end, the fidelity is highly compromised because we have a very low signal to noise ratio. The noise and the crossovers are high in analog communication. And here we come across the digital communication. In digital communication, on the other hand, it does not even involve the faithful reproduction of the baseband waveform. The main problem with the analog communication that we need to faithfully reproduce all the baseband waveforms. This is actually possible if there was no noise. If no noise communication, no loss communication is happening, it is very easy, not very easy, but it is possible to reproduce all these infinite set of waveforms in case of analog communication. Since we are going through a noisy channel, a lossy channel, this becomes a very tedious task. Therefore, in digital communication, we have completely eliminated the idea of a reproduction of these baseband waveforms. Instead, in digital communication, it operates with a finite set of continuous time modulated waveforms, and it is transmitted over a physical channel. This implies that the message signal here, even though the message signal is analog, it must be represented in finite set of voltage baseband waveforms. And this finite set is commonly referred to as symbols or letters, and these symbols consist of fixed number of binary digits or bits. So in digital communication, there is no attempt to faithfully reproduce these baseband waveforms. Even if we encounter noises while transmitting through the channel, it doesn't even matter, because we are not reproducing the baseband waveform at the receiver end. At the receiver end also, we have the same set of finite waveforms, and the receiver will detect the received wave and make a prediction that this particular pulse belongs to this particular voltage baseband. Therefore, the only requirement is that we need to receive the signal, and all the noises which is encountered is completely cancelled out, because now the receiver has a map to choose from. So as soon as this text is received, the receiver will detect the symbol with a high probability, and mostly it is correct. And by the advent of internet, it requires audio, video, imagery and text messages to be integrated for transmission over a single channel. And this also rules out the analog communication systems such as AM and FM. Given here are some of the qualities of digital communication over analog communication. As you can see here, the digital communication is immune to noise and distortion. because at the receiver end what really matters is that whether we receive the signal or not, and all the noises which come in between are ignored at the receiver end. Therefore, the error probability is very low in case of digital communication, and digital communication can make a good prediction of which signal is being received. And the hardware is flexible and less complicated than the analog system. In case of bandwidth and power, we can say that digital communication has a high bandwidth requirement, but it has a very low power requirement. As we have seen, the power requirement is actually to increase the signal to noise ratio, that is to reduce the noise. Since the digital communication does not depend upon the waveforms, initial waveforms, the noise doesn't even matter. So we have a low power requirement, and the portability is very high in case of digital communication. And in digital communication we use pulse coded modulation, and the modulation also involves shift keying, say pulse shift keying, amplitude shift keying, etc. We will see this later. In analog we actually depended upon amplitude modulation, frequency modulation, etc. But here we depend upon pulse code modulation, and the modulation techniques used in digital signal transformation is also highly efficient. So the basic idea is that the shape of the received signal does not even matter. The original pulse which we are transmitting is digitally coded. We know every signal is analog, so we make it a digital signal. Here we employ the idea of digital coding. So basic signal is a digital coded. When it is transmitted through a channel, it will receive noises, and this is our basic digital signal after digitally converting our analog signal. And when we just transmit over a channel will add some noises, some imperfections, some crossovers, etc., and this signal get distorted. But at the receiver end, this signal is reproduced almost identically. As you can see that the data received here and the original data only differs in 1 or 2 bits, that is 1 or 2 pulses, and all other is faithfully reproduced. So the error rate in this type of communication, say digital communication, is very low, and we have a very high fidelity for the messages which are regenerated. Suppose we have repeaters in between. Say if this is our pulse wave, we transmit it over the channel and it get distorted at every point, and while it receive the receiver will faithfully execute this with faithfully consider this, and the same signal is being reproduced without any change, because the noise here is can be neglected, and the pulse is entirely received. And if we have repeaters in between this source and destination, the fidelity of the signal received, the error can be reduced. And this is a whole idea of a digital communication. Let me give you an overall idea about how a digital communication system look like. Any communication system, either digital or analog, will have a structure just like I have shown in this block diagram. It will have a source, it will have a transmitter, and it is transmitted over a channel, say optical fibers or twisted cable wires, and it will have a receiver, then it will have a sink. or a recipient. So for digital communication, this particular block diagram, we had a transmitter and receiver. The transmitter and the receiver block diagram is further divided into several other components. Here also we have a source, a transmitter, a channel, a receiver and a sink. And the transmitter here is subdivided into a transducer, a source encoder, a channel encoder, a digital modulator, and also in receiver end it is been subdivided into a digital demodulator, a channel decoder, a source decoder and an output transducer. So what is the purpose of all these? First, the source, and the signal will be analog, and every signal we produce in music or voice, every signal we produce is analog. So the duty of this transducer is to convert analog signal to digital signal, and it is achieved through sampling. Say we sample the the analog pulse at every ts seconds, and we produce a corresponding digital waveform. It is sampling and quantization. It is the two methods through which we convert analog signal to digital signal. Then it goes into the source encoder. The purpose of the source encoder is to format the signal. So ideally the task of the source encoder is to remove the redundancy from the source. You know, redundancy actually refers to something which is not necessary. So we remove all the unnecessary information and will keep only those necessary information. So this source encoder removes all the redundancy from the source message, and it is coded there, and this is the process where we digitally code. This digital signal produced here after the transducer is then digitally coded, and this coding actually we use alphabets or bits, and the output of the digital encoder is a bits stream or sequence. We have a bit stream is the output of a source encoder, and this bit stream is then inputted into a channel encoder. So the purpose of this channel encoder is to add redundancy into the channel, into the message. Now you will definitely ask me, we had a source encoder which actually removed the redundancy. Now using a channel encoder you are adding the redundancy, then the effect is getting cancelled. So the answer to this question is that we are expecting a noise, crossovers, imperfections in our channel while it is being transmitted. So we need to have some way such as we can predict the errors and correct the errors. So channel encoder add a redundancy in such a way, in a controlled fashion, so that it take care of the error detection and error correction while it reaches the receiver end. So channel encoder, it adds a redundancy, then it moves to a digital modulator. Digital modulator, we have different modulation techniques such as amplitude shift keying, frequency shift keying, pulse shift keying, etc. So all these digital modulation techniques are used so that this message, received message, will have enough energy to be transmitted. This received message here after channel encoding doesn't have enough energy to be transmitted to higher distance. So the main purpose of this modulator is that it provides energy to the signal so that the signal can be transmitted over higher distances. This modulator blocks take the signal or the symbol occurring at every TS seconds, and it is being mapped into a continuous waveform, and which is being set across the channel. And through the channel we have all we receive all the noises, etc., and we reach the receiver end. The channel add noises, interferences, crossover to the messages. Therefore, the channel must be engineered in such a way that the degradation of the signal is reduced. And at the receiver end, we have all the reverse processes as we have done at the transmitter end. In the receiver end, we have digital demodulator. It actually filters out our message from the baseband or the modulating signal which is used, and after that the channel decoder will remove all the redundancy which is being added, and we have a source decoder. Source decoder actually looks up to a map of finite set of waveforms and choose and actually selects which pulse belong to this particular waveform. It predicts its possible waveforms, and then it goes to an output transducer. Here the digital signal is again converted into the analog signal, and then it goes to the signal output. So this is the basic form of this is the basic way in which the digital communication occurs. Now the main purpose of me for using this particular diagram here and explaining all this is because this is basically our route map. This is how we are going to schedule our lecture. So here, coming to the transducer, we have a digital to analog analog to digital conversion, which includes sampling and quantization. Now from the source encoder, we will discuss digital codes, the ideas of digital codes. First, source is actually information, any kind of information, so we will discuss information theory. Then we will look into how the sampling is happening. Then we will look into the ideas of digital codes, how we code, and at the channel encoder, we see it is being used to reduce the error. So we will discuss the error controlling techniques such as error prediction and error detection, error correction, etc. Then we will come to modulator. Here we will discuss different types of shift keying, say amplitude shift keying, frequency shift keying, phase shift keying. There are many advanced shift keying which is not discussed, such as differential phase shift keying, QPSK. It is actually being used in satellite communication. Now in channel we have this waveform being transmitted, and we discuss a lot about noise here, about noise and say bandwidth. We discuss about bandwidth of the channel, the bandwidth which is required for essential transmission. We discuss about power requirements, etc. Now coming to the receiver end, we will discuss about multiplexing, time division multiplexing, and how an analog signal is being transmitted through a digital communication channel, etc. So this particular diagram here actually gives us the route map, a course overview of what we are doing. So what we are doing completely is embedded in this particular diagram. So let me come to the contents of this particular course according to your syllabus. So we will discuss the basics of information theory. The purpose is that the main purpose of communication itself is to transfer information from the source to a destination over a physical channel. So it is appropriate for us to study the course about fundamentals of information theory. Every one of us perceive information in our own way. We have our own outlook towards information. But coming to the idea of communication, it is important that we analyze information in a quantitative manner, mathematically model information. So in this course we will try to quantitatively address information and come with a mathematical modeling which involves entropy, statistics, some probability, etc. So we will look into that. After we have ideas of digital codes, and digital codes, as you know, is used for coding the analog signals. Then we look into noise in information carrying channel. Then we look into digital carrier modulation, and the modulation techniques here we discuss is binary shift keying, such as amplitude shift keying, phase shift keying, frequency shift keying schemes. Then we will look into the bandwidth and the power requirements which is needed for a faithful digital communication. We will discuss about synchronization method. We will discuss the ideas of error control, error correction, digital transmission of analog signals. We discuss about transmission using pulse code modulation. Then we will look into the frequency and time division multiplexing, and time division multiplexing in frequency code modulated telephone systems. So this is how the syllabus goes on. And the two textbooks from your syllabus which we use for study is Digital and Analog Communication by Sam Shanmugam and Electronic Communication System by G. Kennedy and B. Davis. I will be using another book, Digital Communication System by Simon Haking. It is also a very good book. And throughout this lecture, I may be using references from IIT Bombay and MIT Open Courseware available in the Open Coding Systems. Once again, I welcome you all to this particular lecture series, and by the end of this course I hope we will be better acquainted with digital communication. So in this video we have just given an introduction about digital communication. We discussed about how digital and analog communication differs, and the advantages of digital communication over analog communication, the digital communication system, and with that we have discussed a course overview. And for taking this course as a prerequisite, I expect that you have already know about analog communication and about communication channels, etc. So that with that preconception I will be taking the lectures from next day onwards. Thank you.